first section, we're asked to find the measure of angle theta. So since theta, we're given the opposite side and the adjacent side, we'll say theta, tangent of theta is equal to 8 over 3. Now we're asked to find the angle measurement. We use the inverse trig function. Punching in the arctangent of 8/3 into our calculator, we get theta is approximately 69.4 degrees. Number 2, we're also given the opposite and the adjacent side of theta, so we'll have tangent of theta is equal to 8 over 4.2, so therefore the arctangent of 8 over 4.2 is equal to theta. Using our calculator, we'll approximate that theta is approximately 62.3 degrees. Question number 3, again, we know the opposite and the adjacent side. Tangent of theta is equal to 3/4, so arctangent of 3/4 is equal to theta. Theta is approximately 36.9 degrees. In section 4, we're asked to solve for x. Again, we're given our opposite and our adjacent side, so tangent of 43 degrees is equal to 14 over x. We're going to solve this equation for x. To solve the equation for x, we're going to multiply each side by x, and we get x times tangent of 43 degrees equals 14. Now we're going to divide each side by tangent of 43 degrees. So x is equal to 14 divided by tangent of 43 degrees. Punching that into my calculator, I get x is approximately 15. Tangent of 17 degrees is equal to 7 over x. Multiplying each side by x times tangent of 17 degrees is equal to 7. Dividing each side by tangent of 17 degrees, we get x is equal to 7 divided by tangent of 17 degrees. Punching that in my calculator, x is approximately 22.9. Question number 6, this time we are given the adjacent and the hypotenuse. So we have cosine of 62 degrees is equal to x over 6. Solving this equation for x by multiplying each side by 6, we'll get 6 times cosine of 62 degrees equals x. Punching that into my calculator, x is approximately 2.8. This time our directions are to solve for the missing triangle. So we need to solve for all missing sides, which is this BC side, which is the opposite side. So to solve for the opposite side, I got sine of 20 degrees is equal to x over 10. So x is approximately 3.8. So I know that line segment BC is approximately 3.8. Now we're going to solve for AC, which I'm going to call y, and it's the adjacent side. So this time I have cosine of 20 degrees is equal to y over 10. Y is approximately 10.3. Now notice I did not use Pythagorean theorem because BC I used a rounded value to find it. Do not use a rounded number and to find another answer. And finally, to find my missing side, I just take 180 minus 90 minus 20, and I get that measure of angle B is 70 degrees. Okay, let's solve for x, or line segment AB. So we get sine of 40 degrees is equal to 12 over x. X times sine of 40 degrees equals 12, so x is 12 divided by sine of 40 degrees. Punching that into my calculator, x is approximately 18.7, and x is the line segment AB. Line segment AB is approximately 18.7. Okay, let's find line segment AC, which I'll call y. We'll do this by doing tangent of 40 degrees is equal to 12 divided by y. Solving for the y, I get y is equal to 12 divided by tangent of 40 degrees. Y is approximately 14.3. Again, did not use Pythagorean theorem to find that third missing side. To find our missing angle, we take 180 minus 90 minus 40, which gives us 50 degrees. Or I could have just said 40 minus 90. The measure of angle B is 50 degrees. Last one in this section, we'll call AC X, and we'll call AB Y. Tangent of 42 degrees is equal to x over 7. 7 times tangent of 70 degrees is equal to x is approximately 6.3. So line segment CA is 6.3. And then I need to find line segment BAB and angle A. I'm going to call line segment AB y. So I'm going to set up my trig function involving y in the given side 7, and which is going to be the cosine. So y is 7 divided by cosine of 42 degrees. Punching that into my calculator, I get y is 9.4, or line segment AB is 9.4. To find the missing angle, subtract it from 180 degrees, and I get 48 degrees. In this next section, we're given one trig function asked to find the other trig function. So I know cosine is adjacent over hypotenuse, and I want to find tangent, which is opposite over adjacent. So I'm missing my opposite side. So if I draw a triangle and label one side theta, and then I'm going to use this cosine of theta and label my adjacent side 4 and my hypotenuse 5, I'll use Pythagorean theorem to find the missing side. In this case, my missing side is equal to 3. So that means my opposite side is 3. So when I rewrite tangent of theta, this is going to be 3 over my adjacent side of 4. Repeating this process for 11, this time I'm giving cotangent, which is adjacent over opposite. So I know adjacent side is 8, opposite side is 15. Using my Pythagorean theorem, I'll solve for the missing side, which is the hypotenuse. We find that our missing side is 17 degrees. So to find sine, which is opposite over hypotenuse, my opposite side is 15, my hypotenuse is 17, so sine of theta is equal to 15 over 17. Third question, find tangent of theta if sine of theta equals 3 over 5. So 3 is my opposite side, 5 is my hypotenuse. Pythagorean theorem to find the missing side, which is 4. So that means my adjacent side is 4. So tangent theta is opposite over adjacent. So tangent of theta is equal to 3 over 4. I'm going to skip number 13 and go straight to number 14. And anytime you're doing these solve for all 6 missing trig functions, you need to find all 3 sides. So I'm going to use Pythagorean theorem to find the missing side. In this case, I'm going to have my opposite side is 3. Okay, label which side is our opposite, our adjacent, and which is our hypotenuse, looking at the angle theta. Then we're going to find sine of theta, which in this case is 3 over 5. Cosine of theta, adjacent over hypotenuse. Tangent theta, opposite over adjacent. The cosecant theta is the inverse of sine, so I flip it over. The secant theta is inverse of cosine, and the cotangent theta is the inverse of tangent. And that's how you find the 6 trigonometric functions. Number 15, I'm going to do it the same way. I'm going to find Pythagorean theorem to find a missing side. But what's different between 15 and 14 is that I'm going to have to simplify my final answers. Remember to always simplify your answers or rationalize your denominator. None of these examples had rationalizing denominators, but that might show up on the test. So again, labeling my opposite side is the 20, my adjacent side is the 15, my hypotenuse is the 25. So sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta are the angles I need to find. So opposite over hypotenuse, 20 over 25, dividing each of those sides by 5, I end up with 4/5. That means cosecant is 5 over 4. Cosine, adjacent over hypotenuse, simplifies down to 3 over 5, which means secant is 5 over 3. Tangent of theta is 20 over 15, which simplifies down to 4 over 3, making cotangent 3/4. For the geometric series. So I'd have these are 2 parallel lines, and I know these are same side interior angles, and I know the same side interior angles add to equal 180 degrees. Make sure you label which type of angle it is when you show your work on this section. So adding my like sign, so that's the 7x plus the 14x, and then our 9 plus the 3, I get 21x plus 12 equals 180, subtracting 12 from each side, and then dividing each side by 21. I end up that x is 8. These are alternate interior angles, and they are equal to each other. So I would say that x plus 113 is equal to 110. So x is equal to 110 minus 113, which is -3. Number 3, these are also alternate interior angles, and they are congruent. So that means I have x plus 5x is equal to 60, or 60 minus 5 from each side, dividing by 5, I get x is equal to 11. Here we have supplementary or adjacent angles. So adjacent angles are supplementary. That means they add to equal 180. So I have x plus 124 plus x plus 74 is equal to 180. Combining like terms, and then subtracting 198 from each side and dividing by 2. X is equal to negative 9. X can be negative. Number 5 is just like number 1, so I'm going to skip it. If they're same side interior angles and supplementary, you should get an answer of x equals 4. So number 6, they are corresponding angles, so that means they equal each other. So I'm going to set it equal each other and solve for x. And end up that x is equal to 9. Number 7, these are vertical angles, which means they equal each other. Solving the equation for x by subtracting 9 from each side and then dividing each side by 7, you end up that x is equal to 8. 8 is another example of alternate interior angles, and so I would set these two equal each other, and when I solve this down, you should get an answer of x equals 4. Next section, we're going to state if the two triangles are congruent and state how we know. Well, I can get these two angles congruent as vertical angles, and so that means I have an angle side on each triangle congruent. So they're congruent by angle side. Here, by the reflexive property, I know that that line segment that they share is congruent to itself. So that means I have these two triangles congruent by angle side angle. Here, again, the reflexive property says that this shared side is congruent to itself. So these two triangles congruent by side, side, side. Here I could get the vertical angles congruent. And then I have a side angle side. And this other side is not side angle side because the angle between is not the congruent. So I would say here that these two triangles are not congruent. Here I can get these other angles congruent by vertical angles, but then all I know is angle, 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 which is not congruent. On number 14, I can get the shared side congruent by reflexive property. And here I have an angle, angle, then a side, and an angle, angle, side. So these two triangles are congruent by angle, angle, side. And number 15, yet again, I can get the shared side congruent by the reflexive property. And these two triangles are congruent by angle, side, angle. In this section, I want to prove these two triangles congruent by angle, angle, side, and I want to figure out what else is needed. Well, if I can get that vertical angles LMN congruent to angle EMC, and then I can get the side in between those two already congruent angles, which would be the side MN congruent to side MC, then I could have these two triangles congruent by angle, side, angle. Now here are two angles, so I just need the side in between. So if I can get CB congruent to IJ, then I can prove that these two triangles are congruent. For side angle side, I just need the two sides between these two angles. So if I can get side PQ congruent to itself, QP, by reflexive property, and then if I can get side CP congruent to side RQ, I can have these two triangles congruent by side angle side. Here I need another angle and a side. So if I can get angle B congruent to angle C, so that's angle SBC congruent to angle ACB. And if I can get the side BC congruent to the side CB, I could have these triangles congruent by angle, angle, side. Now I could have chose to go the other direction and I could say, okay, let's get angle SBC congruent to angle ABC. And then we can get the shared side BC congruent to the shared side BC. And then that's also angle, angle, side. So there might be more than one way to do these. Okay, on number 20, angle, angle, side, I need to get QM congruent to NM. And I need to get angle QMS congruent to angle NML. And for 21, angle, 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 side, angle, I need the side, and then I need another angle. So let's get ML congruent to LM. Then I need angle KML congruent to angle ILM, and then I'd have angle side angle. Now here, I want to mark on the triangle our congruent sides, so side KJ is congruent to side RI, side JL is congruent to IP, and side KI is congruent to RP. Angle K is congruent to angle R. Angle J is congruent to angle I, which is RIP. And angle I, which is also KIJ, is congruent to angle P. To mark all of them things, we need to mark all three sides and all three angles. And for number 23, here are the three angles and the three sides that are congruent to each other. 24, our last one in this section, we're going to do the same thing. We're going to mark all the sides that are congruent to each other and then all the angles. Okay, we're going to complete the congruency statement, so we're going to look at the names. So WV is congruent to UC, angle VXW is congruent to angle JXI. Okay, angle JKI is congruent to angle JKD. Write our congruency statements. We'll go in the other direction, looking at the congruent angles inside. I can say that triangle STR is congruent to triangle STE. Here, I can say my triangle XNM is congruent to my triangle XWV. Triangle TSR is congruent to triangle GFE. And on 31, triangle HDF is congruent to triangle HJI. Okay, number 2, we're going to do a couple problems out of the book for extra practice. We're given that PQRS is a kite with long and diagonal QS. So we know that QP is congruent to QR, that was given to us in the diagram. And we know that PS is congruent to RS, also given to us in our diagram. Then we can say that side QS is congruent to side QS by the reflexive property. Therefore, triangle QPS is congruent to triangle QRS by side, side, side. In part B, what other facts can we deduce about the figure? Well, we can figure out that all the corresponding angles are congruent to each other. So that's angle QRS is congruent to angle QPS, and angle RQS is congruent to angle PQS. And finally, angle QSR is congruent to angle QSP by CPCTC. Now let's look at number 8. We're going to prove that these two triangles are congruent to each other. So I was given on the diagram that AM is congruent to line segment BM, and line segment CM is congruent to line segment DM. That was given to me. Then I can deduce that angle AMC is congruent to angle BMC because they're vertical angles. And that means that triangle AMC is congruent to triangle BMD by side, angle, side. Part B, deduce that AB and BC are parallel and equal in length. So let's look at equal in lengths first. Well, I know that line segment AC is equal to line segment BD by CPCTC. Also by CPCTC, I know that angle MAC is congruent to angle MBD. Therefore, line segment AC must be parallel to line segment BD because if alternate interior angles are congruent, then the lines must be parallel. For part C, what can we deduce about a quadrilateral ACBD? So let's form quadrilateral ACBD on our diagram over here. Now, from part B, I've already figured out that we found that AC is parallel to BD and that AC equals BD. So to prove that AD and CB are parallel and congruent, let's look at angle AMD and angle BMC. They are also vertical angles, and we know vertical angles are congruent. Then I can get my two triangles off to the side, AMD and triangle BMC, congruent by side angle side. Since those angles are congruent, those triangles are congruent, I can also say that angle DAM is congruent to angle CBM by CPCTC, and therefore AD must be parallel to BC. If alternate interior angles are congruent, then the lines are parallel. Finally, I know that AD is congruent to BC by CPCTC. So now that I have opposite sides congruent and parallel, we can finally say that quadrilateral ACBD is a parallelogram. So quadrilateral ACBD is a parallelogram by the definition of parallelogram, which says opposite sides are parallel and congruent.